Yes, now we'll discuss about the anatomy of internal ear. In previous lectures you have seen the anatomy of external ear, ear pinna, external osteomeatus, tympanic membrane, this is tympanic cavity, and today we discuss about this part, that is internal ear. This is middle ear, this is external ear, this is internal ear. And one very important thing, internal ear, middle ear cavity, Mylius incus stapes ossicles, and mastoid antrum assumes full adult size at time of birth. So this is very important. Now, this is internal ear. Internal ear, if you make a diagram from cutting this point and remove to this part, and see, it will be like this. This is cochlea, this is vestibule, and this part is semicircular canal. This is semicircular canal. This is semicircular canal. This is anterior semicircular canal. This is posterior semicircular canal. And here is lateral semicircular canal. This is lateral semicircular canal. Lateral semicircular canal. So these are three canals, semicircular canals, and this part is vestibule. Vestibule, and this is cochlea. This part is cochlea. Now we discuss about cochlea. In the internal ear, the arrangement is the anterior most structure is cochlea, then vestibule. This is posterior most structure. Anterior, middle and posterior structure. Here this part is anterior, middle and this is posterior structure. So this is anterior most structure, cochlea. If you see the shape of the cochlea, it is like the cell of common snail. It is like the cell of common snail. It is snail-like. Each part of the internal ear has one outermost part, that is bony labyrinth. Within the bony labyrinth there is membranous labyrinth. If you see the arrangement here, outer part is bony labyrinth. Here in this diagram, this is bony labyrinth. Then there is inner labyrinth. Here. Inner labyrinth. Inner bony labyrinth is outer. Inner labyrinth is known as membranous labyrinth. So it is bony labyrinth and membranous labyrinth. This is membranous labyrinth. So bony and membranous labyrinth. Here, between bony and membranous labyrinth, there is a fluid known as, this is perilimb. This fluid is perilimb. Perilimb. And within this membranous labyrinth, here the fluid is endolimb. So this is endolimb. So perilimb and endolimb, bony labyrinth and membranous labyrinth. So here in this diagram, this is bony labyrinth, and from anterior to posterior, cochlea, vestibule, and semicircular canal. 3 semicircular canals: anterior, posterior, and lateral semicircular canal. Now we discuss detail of this cochlea. Here you can see the cochlea is basically, it has 2 components. One part, if you make a diagram here, you can see this is this part. This is internal acoustic meatus. This is internal acoustic meatus, this part. Internal acoustic meatus. This is opening of the internal acoustic meatus, the cranial cavity. This is bottom of the internal acoustic meatus. From here, this is cone-like bony projection. This is modulus. This is internal acoustic meatus. And this is modulus. This part is modulus. This is modulus. And this modulus, surface of the modulus, so spiral projection. Its surface shows the spiral projection. Here you can see this is spiral projection in the surface. This is surface, this is spiral projection. Here is some projection. This is spiral projection on the surface. It is like a screw-like. This is like thread of the screw. You can see this is like the thread present in screw. These are bony projections. This is known as spiral lemma. This bony projection is known as spiral lemma. So this is modulus, and on the surface of the modulus there is a spiral. There is spiral thread-like projection that is known as spiral lamina. And here, this cochlear canal is present here. Around this cochlear canal is present. So this is cochlear canal. So this is cochlear canal which is present here. This is cochlear canal. This is cochlear canal which spirally covers this modulus. This is cochlear canal. Total length of this spirally arranged cochlear canal is about 35 millimeters. And from base to apex, to this, at this from base, this is base to apex, it is about 5 millimeters. And the maximum transverse diameter is about 9 millimeters. If you cut a section like this, you will find this is conical projection. This is modulus. Here, internal acoustic meatus open. This is the bottom of the internal acoustic meatus. This cone is modulus. Here, numerous openings are present. This opening gives passage. This opening is the spiral tract. This opening gives passage for the cochlear nerve. Fibers of the cochlear nerve passes through this opening. And here, if you cut a section like this and separate, this is position of the cochlear canal. These are the cochlear canals in the section. If you cut like this, then here is position of the cochlear canal. This is cochlear canal. So these are the cochlear canal. If you see, here is position of spiral lamina. This is the spiral lamina. This is position of the spiral lamina. Which already here discussed. The spiral lamina. This is spiral lamina. This spiral lamina divides into two lips. This spiral lamina divides into two lips. These are the two lips. One lip is tympanic lip and another is vestibular lip. So one is tympanic lip and vestibular lip. And here, this is tympanic lip. This lip is tympanic lip. And this is vestibular lip. And here, basilar membrane is attached here, and here, vestibular membrane is attached here with this lip, and basilar membrane attached to this lip. Here is basilar membrane, Here is vestibular membrane. Here is basilar membrane, vestibular. Basilar membrane, vestibular. By these two membranes, this cochlear canal is divided into three parts. One part which is towards the apex. This apex is towards the apex. This part, this part, this part, and this part. This is known as scala vestibulari. This is known as scala vestibulari. And here, this part, this part, this part, and this part. It is known as scala tympani. So, the part of this cochlear canal above the vestibular membrane, this is vestibular membrane, is the scala vestibuli. And part below this membrane, this basilar membrane, below this basilar membrane is scala tympani. The scala vestibuli and scala tympani both contains perilimb. So perilimb is present in both. And in between these two, scala vestibuli, scala tympani, there is this portion, this portion, this portion. This is known as scala media. This part is known as scala media. This is known as, this part is scala media. This is scala media. When it's scala media, this is scala media, this is scala media. This scala media, it is also known as cochlear duct. This is cochlear duct. In cochlear canal, this is positioned the cochlear duct between scala vestibuli and scala tympani. This cochlear duct. This cochlear duct at the apex it is a blind duct. We'll discuss that. And here, scala tympani and scala vestibuli joins with each other. These two joins with each other and become continuous with each other at the apex. This apex is known as cupula. Here, this apex is known as cupula. And the apex here, these two become continuous. If you make a simple diagram, here is position of spiral lamina. This is spiral lamina. This is spiral lamina. Here is this is, if you simplify that diagram, you can see this is oval window. Here, foot plate of stabilized lies. Here, this is oval window. And here is, this is round window. Here secondary tympanic membrane is present. Here secondary tympanic membrane is attached. This is child lamina, secondary tympanic membrane. And this portion is spiral lamina. This portion is this spiral lamina. This is spiral lamina. In in this diagram. This is spiral lamina, and this is apex. This is apex, that is cupula. This is cupula, and the cupula you can see this part is. You can see here. This is spiral lamina. This spiral lamina divides this canal into this part and this part. At this level, you can see here. This up to this level, you can see upper part is this and lower part is this. Upper part is this. Upper part is scala, vestibular. This is scala, tympani. And here you can see these two parts communicate with each other at the apex, at the cupula. At the cupula, the scala vestibuli and the scala tympani continue with each other. And now see another thing. If you remove here, if you remove this bony covering, then you can see here, this is position up, this is position up, here from this part, bony part is removed. Now here you can see this is an ear structure, you can clearly see. We are seeing this spiral lamina, this is spiral lamina. This is spiral lamina, and here you can see this opening. This is opening through which scala vestibuli and scala tympani communicate with each other. Scala vestibuli, scala tympani communicate with each other through this opening. This opening is known as helicotrema. This opening is known as helicotrema. This is helicotrema, this opening, through which scala vestibuli communicate with scala tympani at the cupula. This spiral section passes through this level. This level. It is that. Here, spiral lamina, scala vestibuli, scala tympani, scala vestibuli, scala tympani. And here you can see this scala vestibuli. This is scala vestibuli. It communicates here. Scala vestibuli communicate with middle ear, and here oval window is present. So here oval window is present. If you here bony part is intact, this is opening, this is oval window. And here is a round window. This is positioned as a round window. This is a round window. This is a round window. So this round window is scala tympani, you can see here. Communicate with round window. And here secondly, tympanic membrane is attached. And here stapes is attached. And another one important thing, this opening is round. And the opening here, you can see, here is one duct, that is aqueduct of cochlea. This aqueduct of the cochlea, this aqueduct of the cochlea it communicates with subarachnoid space. So here lies subarachnoid space. So it communicates with the subarachnoid space. Where cerebrospinal fluid is present. So here it communicates with CSF through this aqueduct of the cochlea this perilimb communicate with this CSF into the subarachnoid space. So here lies perilimb, here lies perilimb. Now another thing here, in between these, here lies endolimb. This is membranous labyrinth. So till now we have seen the bony labyrinth. This is bony labyrinth. In next lecture we will discuss about the membranous labyrinth. This is membranous labyrinth here. This is membranous labyrinth. If section passes through this level, then this membranous labyrinth and scala vestibuli, scala tympani, you can see. So here in this lecture, if this section passes through this level, this spiral section, here the scala vestibuli and tympani is the scala vestibuli, scala tympani, and in between the spiral lamina. Spiral lamina, scala vestibuli, scala tympani. Cochlear duct. This cochlear canal or duct length is about 35 mm. From here to here is 5 mm. From here to here, this, at the base, it is 9 mm. And direction of this apex or cupula, it is directed on lateral side. And this is base lies on the, this is internal acoustic meatus, so and lies on the bottom of the internal acoustic meatus. So here is base, here lies apex. This is apex is known as cupula. And here you can see, this is spiral lamina, this is modulus, this is spiral lamina, and this is the cochlear canal. And turn of the cochlear canal around the modulus is about 2 and 3/4 turns. So this cochlear canal makes 2 and 3/4 turns around this modulus. And this by spiral canal, this canal is divided into 3 parts. This part is scala vestibuli, towards the apex, towards the base, scala tympani. And in between these two, here is scala media. This scala media is also known as cochlear duct. It forms the membranous labyrinth. Here, if you see the section passing, in previous lecture you have seen section, spiral section passes through this level. Where this is scala vestibuli, scala tympani, and in between the spiral lamina. If section passes through this level, then here is position of this part is cochlear duct. So here cochlear duct is formed. This is cochlear duct. If you remove from this side, bone is removed here, the covering, and you can see easily this duct. This is cochlear duct. Here you can see this cochlear duct at the apex, at the cupula. This is blind. This cochlear duct is blind here. It ends here. This is cochlear duct, and this is blind. This blind part is known as lamina. This is lamina, this blind part. And this part is scala vestibuli, this is scala tympani, and this is cochlear duct. scala media. This is scala media or cochlear duct. And as you know, as we discussed in detail, here is position of this is ductus radians. This is ductus radians. This is ductus radians from here to here, and this is sacral. So here it communicates with sacral. So this is membranous labyrinth. This is membranous labyrinth. Here in membranous labyrinth, in this part, organ of carti, spiral organ of carti is present. That is organ of hearing. Here organ of carti is present. If we make diagram like this, here is position of this is modulus. This is modulus. This part is enlarged, magnified part of this. This part is magnified here. So here is position of spiral lamina. The spiral lamina divides to two lips. One lip is here, one lip is here. By a sulcus, C-shaped sulcus, this is C-shaped sulcus. The spiral lamina is divided into two parts, two lips. This lip is vestibular lip. This is tympanic lip. By C-shaped sulcus, here this sulcus is C-shaped. This is known as sulcus spiralis internus. Sulcus spiralis internus here. On lateral side here, one important thing is this is crista basalis. This is crista basalis. And here is sulcus is present here. And the sulcus, this sulcus is known as, here this sulcus spiralis internus, and this sulcus is sulcus spiralis externus. Sulcus spiralis externus. And here one membrane is attached. This is basilar membrane from here to here. This is basilar membrane. Basilar membrane attached from the tympanic lip of this spiral lamina. This is spiral lamina. Tympanic lip of the spiral lamina to crista basalis. And another membrane here is this is resonance membrane or the vestibular membrane. This is vestibular membrane, also known as resonance membrane. Viscous membrane. So here this part is scala, vestibuli, scala, tympani, and this is scala media, and here is scala media. This is side where endolymph is formed. Endolymph is formed by here. Here is three layered simple squamous cells. Here vascular supply is very rich, and this is known as stria vascularis. This part is known as stria vascularis. Here endolymph is formed. Endolymph is formed. So here endolymph is formed. This is endolymph. So endolymph forms. This is filled by endolymph. This is filled by perilymph. So endolymph is present here. And another very important thing, here organ of Cartile is present. What are the cellular structures which form the organ of the Cartile? Organ of hearing. Here in the basement membrane, this is hair cell is present. Here is hair cell, flask-like cell. This is hair cell, and it has stereocilia. This is inner hair cell, and here lies outer hair cell. Outer hair cell. This is outer hair cells. So here, this is inner hair cell. These are the stereocilia. If you see the stereocilia in the inner hair cell, this is inner hair cell. Inner hair cells, and there are three are the outer hair cells. Three rows of the outer hair cells. If you see the structure of the inner hair cell and outer hair cell, this is inner hair cell. Here is like this. Here is centriole, and here if you see the arrangement of the stereocilia, it is U-shaped. It is U-shaped arrangement of the stereocilia is here. And in case of the outer hair cell, these are the outer hair cells. Here arrangement of the stereocilia structure is same, but arrangement of the stereocilia is W-shaped. There is a centriole, and the arrangement of the stereocilia is here W-shaped. There is U-shaped. So these are difference between these two. And here, afferent neurons are present. Here are afferent neurons, neurons. Here, small foramens present in this spiral lamina through which this nerve passes, and here is spiral ganglion, and from here the cochlear nerve. This is bipolar neuron. This is cochlear nerve. So these are the stereocilia. And another thing, these are the hair cells, inner and outer hair cells. Now in between these cells, there are different color. These are the rod cells. Here you can see these are the two rod-like cells. These are the rod cells. Inner and outer rod cells. Inner and outer rod cells. If you magnify this diagram, here, here is inner hair cells, then rod cells. Rod cells is like this, like rod. This is inner rod cell. This another rod cell is like this. Outer rod cell. In previous lecture of the internal ear, you have seen anatomy of the cochlea. Now we'll discuss about anatomy of the vestibule. Here this is vestibule, and here is semicircular canal. This is cochlea. This is anterior-most structure. This is posterior-most. This is middle structure. Here this is external acoustic meatus. This is external acoustic meatus. This is medial ear cavity. This is lateral wall of the middle ear. This is medial wall. Here is medial wall. And here you can see this medial wall. Here is opening. This is fenestra vestibuli. This is fenestra vestibuli. This fenestra vestibuli present in lateral surface of vestibule. This is vestibule. Here is vestibule. So this is vestibule, and here if you make so this is vestibule. These are three semicircular canals. So this is lateral wall. If you see the lateral wall has, this is fenestra vestibuli. This is fenestra vestibuli. Here, another ligament is attached to margin of this. As you know, another ligament is attached, and through this another ligament, foot plate of stapes is attached. Here, foot plate of stapes is attached. Here is stapes. Here is foot plate of stapes is attached and covers this. Here lies the foot plate of stapes. So this is lateral wall. It has another walls. It has anterior wall. If you cut a section like this here and remove this anterior wall, if you remove this anterior wall, then you will find this is bony labyrinth. Then you will find membranous labyrinth. Here in the cavity vestibule, membranous labyrinth is present. So here lies membranous labyrinth. After removing the bony labyrinth, membranous labyrinth is present. And if you remove this membranous labyrinth, then you can see this is medial wall. This is here lies medial wall. This is medial. Lateral wall removed. Now this is medial wall. In medial wall, here is the crest. Here the crest is present. This is known as, this is vestibular crest. So in medial wall there is a crest known as vestibular crest. By this vestibular crest, it is divided into two recesses here. Here a recess is present. This recess is spherical recess. And this is elliptical recess. So two recesses are present here. Elliptical recess and this is spherical recess. Here you can see here numerous foramen. These are the numerous foramen present in these recesses. This foramen is for which foramina is for the here in the elliptical recess, the foramina for the upper fiber of vestibular nerve. So upper fiber of the vestibular nerve. And here in this foramen, so this foramen upper fiber of vestibular nerve passes out, and through these foramina in spherical recess, here lower nerve fiber of the vestibular nerve fibers from the lower fiber passes through this, and upper fiber passes through this foramen. Now here is under recess. Here lies under recess. This is cochlear recess. Here is cochlear recess. This is cochlear recess. It is formed by vestibular crest, divides inferiorly into two lamina. Between two parts there is a recess known as cochlear recess. Through the cochlear recess, cochlear nerve passes. Cochlear nerve fibers passes. And here is another opening below to this. There is another opening here. Below the elliptical recess there is another opening. This is opening of the, this is aqueduct. This is aqueduct of vestibule. Aqueduct of vestibule. This is aqueduct of vestibule. So this opening is aqueduct of vestibule. Through this duct, the structure passes, that is part of tubular extension of the membranous labyrinth. Through this tubular extension of membranous labyrinth passes through this. That is known as, is like this. From here, this is tubular extension from this opening. This is ductus endolymphaticus. And this is saccus endolymphaticus. So this is part of membranous labyrinth which extends. It reaches into the epidural space, and here epithelium of this absorbs the endolymph. Here this absorbs the endolymph. So this is ductus endolymphaticus and saccus endolymphaticus passes through this foramen, that is aqueduct of vestibule. So this is medial wall where you have seen numerous structures. Now you can see the anterior wall. Here is anterior wall. Here is anterior wall. This is anterior wall. Here lies scala vestibuli. Here is scala vestibuli. This is scala vestibuli. And as you know, spiral lamina passes through this. Previous lectures you have seen, spiral lamina passes through this, like this, and it divides into scala vestibuli and scala tempori. So this is scala, this opening communicate with the scala vestibuli. This is the scala vestibuli. This tube is scala vestibuli. If you see on posterior side, posteriorly, here you can see this is posterior wall. Here these openings, these are the 5 openings. These are the 5 openings present in the posterior wall. These are the 5 openings present in the posterior wall. These openings are for this is anterior semicircular canal. Here is crus commune. This is lateral semicircular canal. This is lateral semicircular canal, and here is posterior semicircular canal. So these openings are present in the posterior wall. So this is a bony labyrinth, and as you know, between anterior and posterior, between lateral and medial wall, there is membranous labyrinth. So here is membranous labyrinth. Here is position of the saccule. This is position of the saccule. This saccule is attached with, this is ductus reuniens. Through this ductus reuniens, it is attached with scala media. Between scala vestibuli and scala tempori, there is scala media, which is known as cochlear duct. So here cochlear duct joins with the cochlear duct. This is cochlear duct. Here you know this is blind at the apex of the cochlea. Here scapula is present. This is the cupula. Here is the blind. This is end of this cochlear duct, and this is known as lagina. This blind end is known as lagina. So this is cochlear duct. By ductus unius, this membranous labyrinth, here is, this is saccule. And here is and this is utricle. This is known as utricle. So this is utricle, this is saccule. Here is Y-shaped connection between utricle and saccule. This is Y-shaped connection. This is known as utriculosaccular duct. So this is utriculosaccular duct. This is utriculosaccular duct, and this duct passes through this foramen, this opening, that is aqueduct of vestibule. It passes through this opening. It is like this. It has ductus endolymphaticus. This is ductus endolymphaticus part. This is ductus endolymphaticus. This is saccus endolymphaticus. And it communicates with 3 semicircular canals. Now, in utricle and saccule, there is macula is present. There is macula. This is known as macula. These are the macula. Yes. Now we'll discuss about the internal ear part 4. In this part, we'll discuss about the histology of the macula. We'll discuss about the macula. and also 3 semicircular canals. So first of all, 3 semicircular canals. Here you have seen, this is Membranous Labyrinth, this is Sacule, Utricle, here is Cochlear Duct, and here is Ductus endolymphaticus, Sacus endolymphaticus. We have 3 semicircular canal. This is superior or anterior semicircular canal, superior or anterior. This is lateral semicircular canal, and this is posterior semicircular canal. If you cut a small part of this, it is like this. This is bony labyrinth. Within the bony labyrinth, there is membranous labyrinth. This bony labyrinth, diameter of the bony labyrinth, you can see here, and this is membranous labyrinth. It is 1/4 of the bony labyrinth. Diameter of the membranous labyrinth is 1/4 of the bony labyrinth. And here perilymph is present. This is perilymph, and here endolymph is present. This is endolymph, and this is, here is fibrocellular structure. This is fibrocellular structure through which this is suspended through this membranous labyrinth is suspended within the bony labyrinth. So this is fibrocellular structure. Here you can see these are the 3 semicircular canal, and 1 semicircular canal is about 2/3 of a circle. It is about 2/3 of a circle, and length of 1 canal is about 15 to 20 millimeter. And important thing, if you see the direction, here is anterior canal fossa. Here is, this is pictus temporal bone. This is pictus temporal bone. This is anterior surface. This is posterior surface. This is pictus temporal bone. And position, if you see the position of the ear, position of the internal ear here. This is position of the semicircular canals. Here lies, this is lateral semicircular canal, and this is anterior semicircular canal, and here is posterior semicircular canal. So this is posterior semicircular canal, and here this anterior semicircular canal form an eminence known as arcuate eminence. So in the anterior surface of the pectus temporal bone, here this is arcuate eminence is formed. This is arcuate eminence. If you enlarge this view, here is position of This is lateral semicircular canal of this side, and here is lateral semicircular canal of this side. This is ampullary end, dilated end. Here, this dilated end is ampullary end. This is ampullary end. This is dilated end. Direction of the ampullary end. This is in the lateral semicircular canal. This is lateral semicircular canal. Direction of the it is anterolateral. This is anterolateral direction. This is anterolateral in direction. And this convexity is towards the backward. It is posterior. Posterolateral. Convexity is posterolateral. This convexity is posterolateral side. And here, another thing, this is superior semicircular canal or anterior semicircular canal. Here, this is ampullary end. This is superior semicircular canal. It has ampullary end. This is ampullary end. Direction of the ampullary end is anterolateral. This is anterolateral in position. And you can see this is superior semicircular canal or anterior semicircular canal. And this is here is long axis of the pectus temporal bone. Its position is 90 degree with the long axis of the pectus temporal bone. So it is right angle to long axis of the pectus temporal bone. So this is, and its convexity is, it is convex upward. Its convexity is upward. And here, this is superior semicircular canal, and this is inferior semicircular canal joined to form crus commune. This is crus commune. This is crus commune. This is crus commune. So here, this is crus commune. Here, posterior semicircular canal joins with the superior semicircular canal. And here is this is dilated end, this is ampullary end. Direction is it is downward, that below. And direction of this convexity, here it is backward. And its long axis, you can see here, the long axis is parallel with the long axis of the pectus temporal bone. So this lies along the pectus temporal bone, and this lies right angle to the long axis of the pectus temporal bone. This is horizontal in position. When it is tilted about 30 degrees forward, then it becomes horizontal. So when tilted, head is tilted 30 degrees forward like this, then its position becomes horizontal. Its position becomes horizontal. And here is position of anterior, this is posterior. And you can see this anterior is parallel with posterior semicircular canal of opposite side. This anterior semicircular canal is parallel with the opposite posterior semicircular canal. And here in the ampulla, crista ampullaire is present. In the ampulla here, crista ampullaire is present. Here is crista ampullaire is present in the ampulla. Here is crista ampullaire is present in the ampulla. This is crista ampullaire. Crista ampullaris. So this crista ampullaris, it is responsible for angular acceleration and kinetic equilibrium. Responsible for angular acceleration and kinetic equilibrium. So angular acceleration and kinetic equilibrium. If you see histology of this, you will find it is like, here is position of the bony labyrinth, membranous labyrinth. This is membranous labyrinth. You can see this membranous labyrinth is within the bony labyrinth like this. This is membranous labyrinth. And here is position of this is gelatinous cupula. This is known as cupula. This is made up of gelatinous substance. This is cupula. And here is numerous cells. These are flask-like cells. Flask-like cells are type 1 hair cell. This is type 1 hair cell. Here, this is kynocelia and several stereocilia is present. Here this is kynocelia. Kynocelia is 1 in number and stereocilia, numerous stereocilia. Stereocilia is about 70 to 80 in numbers. So this is type 1 hair cell, this is sensory cell. And the sensory cell is, this is elongated columnar cell. It has also kynocelia and stereocilia. Here is nerve which attached to this. This is afferent nerve, and some efferent also goes to this. And here are some supporting cells. These are some supporting cells. This is supporting cell. And lateral to this, there are numerous cells. Lateral to the supporting cell, there are numerous cells, which is known as cells of Planus semilunaris. This is cells of the Planus semilunaris. So this is crista ampullaria. And another thing you can see here, another sensory structure which is present in the circular nuclei, that is macula. If you see histology of the macula, this is otolithic. This is otolithic membrane. This is otolithic membrane. And below this membrane there is calcium crystal. These are the calcium crystal. These are the calcium crystal. So this is calcium crystals. And here this is basement membrane. Here is basement membrane of basal lamina. And here cells are present. Again, this flask-like cell, which with kinetocilia and stereocilia, like here. This is type 1 cell. And another type of the cell, here you can see, this is elongated cell, stereocilia and some cilia. Stereocilia and kinocilia. Kinocilia and stereocilia. Here number is also, kinocilia is 1 and stereocilia is 70 to 80 numbers. This is flask shaped and this is elongated columnar cell. This is type 1 hair cell, this is type 2 hair cell. Type 1 and type 2 hair cell. And in between these, there is some supporting cells. This is supporting cell. Here lies some supporting cells. And here is the position of sensory nerve cell, afferent and some efferent fibers also join with this. So this is histology of the macula. So this is all about the internal ear part 4. Thank you. Now we'll discuss about the anatomy of vestibulo-cochlear nerve. Vestibulo-cochlear nerve is 8th cranial nerve. So here, first of all, to make a diagram, here is position of. Here you can see this is circular. This is utricle. This is Cellular Duct. Right side. This is anterior semicircular canal. Anterior semicircular canal. This is posterior semicircular canal. This is anterior semicircular canal, and here is lateral semicircular canal. This is lateral semicircular canal. This is utricle. And in utricle and circle, here is macula. This is macula. And here, ampullary crest is present. This is crista. These are crista ampullae. Crista ampullaris. And here is ductus reuniens. This is ductus reuniens. And this is cochlear duct. This is cochlear duct. In cochlear duct, here is organ of the carti. This is position of the organ of the carti, which is present in the cochlear duct. If you cut a section of this, you can see here, this is cone-like modulus. In modulus, here the foramen is present. And here is position of cochlear ganglion. This is cochlear ganglion. And another thing, here is position of bottom of, this is bottom of internal acoustic meatus. Internal acoustic meatus. And this is divided into two parts by crest. This is crest. This is superior, this is inferior. This superior vestibular area is here. Inferior vestibular area. This is superior and this is inferior. Vestibular area. Here is opening of the facial canal. Here is foramen of tactus. This is tractus, spiralis, foramen. And here is one another foramen. This is foramen singulaire. This foramen singulaire. And if you see another diagram here, after this is transverse section of transverse section of pons. This is transverse section of the pons. At inferior level, this is inferior cerebellar peduncle. Here line, this is inferior cerebellar peduncle. If you see, here is dorsal cochlear nucleus, here is ventral cochlear nucleus. This is dorsal cochlear nucleus. This is ventral cochlear nucleus. And here is position of vestibular nuclei. These are vestibular nuclei. There are 4 vestibular nuclei. These are 4 vestibular nuclei. We are superior, inferior, medial and lateral. There are superior, inferior, medial and lateral vestibular nuclei. And ganglion of the vestibular is present in this internal acoustic meatus. So here is position of the ganglion. This is bipolar ganglion, and here you can see the cochlear ganglion is present here. In the modulus, if you cut a section here, this is modulus around which the cochlear ducts are arranged, and here is cochlear duct, and here is position of spiral lamina and vestibular membrane. This is cochlear duct. This is cochlear duct. And here organ of Carti is present. In this area, here organ of Carti is present here. Organ of Carti is present. So, here is position of these nuclei, vestibular nuclei, and this is vestibular ganglion. Vestibular ganglion is also known as Scarpa ganglion. Scarpa's ganglion. If you see this thing in lateral view, here is midbrain, this is pons, this is medulla oblongata, midbrain, pons, medulla oblongata. Nuclei are present here. This is position of the nuclei, vestibular and cochlear nuclei. And this is junction of, here is junction of pons and medulla. This is pons and medulla. At the pontomedullary junction, pontomedullary angle, this nerve arises. And component of this nerve is, it has a special somatic afferent fiber. These are sensory fiber and proprioceptive fibers. A special somatic afferent. And also some fibers. So special somatic fibers arise from dorsal ventral cochlear nuclei and vestibular nuclei. We have a special somatic afferent. And some fibers are arise from the superior olivary nucleus, superior olivary and accessory olivary nucleus. These superior olivary nucleus extend from lower part of the pons to upper part of the medulla. So here lies, this is superior olivary nucleus. The superior olivary nucleus and also accessory olivary nucleus. So both nuclei gives efferent fiber. So efferent fibers are also present. So very few number of efferent fibers here. If you see the number of the fibers here of the vestibular nuclei, vestibular fibers are around 19,000. And cochlear fibers around 23,500. And there are very few fibers, apparent fibers. So these nerves, so in this diagram you see, this is nerve, vestibular cochlear nerve. It is lateral in position to, here is position of the abduction nuclei, and this is facial nerve. So it is lateral to the facial nerve. This is facial nerve and this is vestibular cochlear nerve. This is lateral in position. And from here, you can see this vestibular cochlear nerve here passes to this. Here is ganglion, this is vestibular ganglion, and here is cochlear part. Here, this is cochlear. Its ganglion passes, its nerve passes through this, and its ganglion lies here. So this is ganglion, this is cochlear ganglion. That means here is, if this position is here, then it lies in the modulus, and the vestibular ganglia or scarpa ganglion lies in the internal acoustic meatus, and this ganglion, cochlear ganglion, lies in modulus. So from here, fibers go into the modulus. This is modulus, and here the foramen is known as tractus spiralis foramen. It passes through tractus spiralis foramen. And here you can see, so fibers from these, nerve fibers from these, this is cochlear duct, here this is cochlear duct, and here you can see the hair cells. Here are inner hair cells, this is outer hair cells. If you enlarge this like this, here lies inner hair cells. These are inner hair cells and outer hair cells. So inner hair cells are connected with this inner hair cell. One inner hair cell connected with about 10 ganglion cells, and outer hair cell. If you see outer hair cell, so one ganglion cell is one ganglion cell peripheral process attached with the 10 outer hair cells. So one peripheral process of one ganglion cell is attached to 10 outer hair cell, and inner hair cell, one inner hair cell is attached about 10 cochlear cells. So 10 nerve fibers of the cochlear cells. So here one inner hair cell attached with the 10, and 10 nerve fiber attached to, one nerve fiber attached to 10 outer hair cells. So one nerve fiber attached to 10 outer cell, and one cell of the inner hair cell attached to 10 nerve fibers. So from here, this nerve goes like this, the ganglion. This is ganglion. From here, nerve goes to the internal gastric meatus through this opening, and here you can see this is macula. In the cyclone, this fibers goes through the inferior vestibular area. It goes through the inferior vestibular area, and this is superior vestibular area, and here the fibers from the utricle, macula of the utricle goes into this, and fibers also ampullary crista or crista ampullaris from the anterior and lateral semicircular canal goes into the superior vestibular area. And a very important thing is this is posterior semicircular canal. Here this is crista ampullaris. From crista ampullaris of the superior posterior semicircular canal, fibers goes through this opening. This is foraminous singulare. Through it passes into the ganglion. So this is the vestibulocochlear nerve connection. Thank you.